Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 44, and this problem asks us to explain the following statement. 2-methoxyacetic acid is a stronger acid than acetic acid. However, para-methoxybenzoic acid is a weaker acid than benzoic acid. Why? Well, let's look at the effects of this methoxy group. So both of these, we have this methoxy group versus no methoxy group. So here, what we know about acidity is that, well, the stronger the acid, the more stable the conjugate base. So just like before, there's 3 ways you can stabilize a conjugate base. Number 1, putting the negative charge on an electronegative atom, such as oxygen. Number 2, resonance stabilization, which both of these will have. And number 3, inductive stabilization of the negative charge. And what does that mean? That means that by having some sort of electronegative atom on a molecule in close proximity, we can inductively pull electron density away from this carboxyl group and towards these electronegative atoms to further stabilize a conjugate base. And if you look at this, the methoxyacetic acid, well, the methoxy group is bound to an sp3 hybridized carbon, so there's no actual way that you can resonant donate electron density into the ring. Therefore, the only effect that you will see is that inductive stabilization effect of pulling that electron density away from these 2 oxygens and towards the methoxy group down here. Therefore, further stabilizing the conjugate base than acetic acid, which has no methoxy group, and therefore this methoxy version is going to be more acidic than just acetic acid on its own. But now if we move down here in this benzoic acid, so yes, this methoxy group will have some sort of inductive pull of electron density, but because it's hybridized to an sp2 carbon, you can actually have electron donation into the ring. So you can actually electron donate into the ring to form now a resonance structure that puts a negative charge. This is a negative charge. So you're going to put a negative charge on this carbon, which is adjacent to the negative charge that's right here. So you're going to have 2 negative charges that are in such close proximities to one another. So the resonance stabilization effect outweighs the inductive stabilization effect. So because methoxy resonance stabilizes and resonantly donates electron density into the ring, it will destabilize the negatively charged conjugate base. Therefore, the benzoic acid that has no electron donating a substituent on it will be more acidic than this methoxy version of this benzoic acid that will have the substituent that will donate electron density into the ring.